In this video, we're going to pick up where we left off, where Kw equals the concentration of hydroniums times the concentration of hydroxides. Now, Kw is a value that's given in your data booklet, and Kw equals 1.0 times 10 to the negative 14. And so the Kw value is going to be able to be used if I know the hydronium concentration, or hydroxide concentration, I can calculate hydroniums, or vice versa. So if I know the hydronium, I can calculate the hydroxides. So we're going to do a couple of questions that look like that here. So here we've got the hydronium concentration in industrial effluent is 4.4 millimole per liter. Determine the concentration of hydroxide ions in the effluent. If you have, I would encourage you to pause this for a second and then go through the answer to check to see what what you're doing. So if the hydronium concentration is 4.40 millimole per liter, millimoles are 10 to the negative 3. So it's 10 to the negative 3 mole per liter. The concentration of hydroxides will equal Kw divided by the concentration of hydroniums. So 1.0 times 10 to the negative 14 divided by a concentration of 4.40 times 10 to the negative 3 mole per liter. And we should be able to do this calculation directly. So we'll take 10 to the negative 14 divided by, and so I'm coming out with a concentration of 2.3 times 10 to the negative 12 mole per liter. And so that would be the concentration of hydroxides in this acidic solution. So you can see that it's acidic, it's got more hydroniums, and so we're going to expect a fairly low concentration of hydroxides. So that makes sense. If we did the next, I'll let you do question 2, but let's take a look maybe at one that's a little bit more tricky. So here we've got the calculate the hydroxide ion concentration in a solution prepared by dissolving 0.37 grams of hydrogen chloride. So our mass of hydrogen chloride is 0.37 grams, 0.37 grams. The molar mass of hydrogen chloride is going to be 36.46 gram per mole. And we were dissolving it in 250 milliliters of water. So the volume is going to be 250 milliliters, which is 0.250 liters. And so my number of moles of hydrogen chloride is going to be 0.37 grams. I'm going to get rid of grams, be left with mole. So 1 mole is 36.46 grams. So I'm coming out with 0.010148 mole. And if I want the concentration of hydrochloric acid, I'm going to take 0.010148 mole, and I can divide it by the volume in liters, so 0.250 liters. And so I get 0.040592 mole per liter. So that's the hydrogen chloride. Now, hydrochloric acid is a strong acid. So the concentration of hydrochloric acid will be the same as the concentration of hydronium. So the hydronium is 0.40592 mole per liter. Now, the reason that occurs is that it is a strong acid, and the strong acids are listed here in our data booklet, and any of those strong acids quantitatively react. So HCl plus H2O, 100% of it becomes hydronium plus a chloride ion. And so when we were doing this question here, the concentration of hydrochloric acid is the same as hydronium because it's a strong acid and it's a quantitative change. So the concentration of hydroxides will equal Kw divided by the concentration of hydronium, which in this case is the same as the hydrochloric acid because it's a strong acid. So I'll take 1.0 times 10 to the negative 14 divided by 0.040592 mole per liter. And so then I'm going to take 10 to the negative 14 divided by that. And I'm going to come out with 2.5 times 10 to the negative 13 mole per liter for hydroxide ion concentration. And so complete the rest of these. The answers for these are on page 716. I'm not encouraging you to bother doing the last one. So do 1 to 5, and we'll catch you in the next video.